last but not least, our dean from Agoric is going to talk about the future is much more programmable. So please welcome Dean on the stage, guys. Thank you.
Do I have slide buttons? Do I have a mic? Whoa. You're going to want to turn that down because I was going to make a loud noise in a little bit. All right. So I'm Dean Tribble, as she said. I am CEO of Agoric. And Agoric is a Cosmos-based, Tendermint-based smart contract platform for general-purpose platform for writing smart contracts in JavaScript. And where if you're going to attract millions of developers, you have to meet them where they're at. And there are 6,000 developers, according to Electric Capital, that can program a decent Solidity contract. There are 14 million JavaScript developers, of which at least 10 million could construct a decent JavaScript program. And if you want to take over the world's economy, those are the people we need to reach. And you don't reach them with just a language, you reach them with components, with a component model, sort of the best practices for being able to put things together, the best toolkits like VS Code and so forth. And so that's the core of how we will reach the next generation of developers out there. And then finally, the other element of the Agoric platform, it has an integrated economy. So, we discovered a few thousand years ago that paying for execution, paying for rent, paying mortgages, whenever those were invented, is much better done with a currency. The world right now of crypto is a lot more like a barter economy, where I pay with a volatile commodity that might be worth twice as much tomorrow as it was today. And so this integrated economy has interprotocol, which we'll talk about in a minute, that is a stable token, the #1 stable token in the Cosmos ecosystem, or native stable token in the Cosmos ecosystem. And so that's a big part of the platform and synergistic and part of the reward structure and all that kind of thing. So we've been working on it a long time, but June was a really big month. In June, we shipped the general purpose platform. We shipped independently upgradable smart contracts. So if you've got an application built from multiple smart contracts, they can have their own governance that then determines how they get upgraded. We shipped state sync. I don't know how familiar folks here are with Cosmos. It has this notion of state sync, where I can bring in a new validator, a new operator of the network, and they can pull down from the internet a cloud of data that they can just start running from without having to trust any one other party, and they know they're starting from the consensus state of 100 other machines. Now that's really impressive in Cosmos. But what we added to that is, we're about programming in JavaScript. And JavaScript applications are long-lived programs. They sit there in memory. They compute for a long time, unlike the rest of the blockchain where they compute in little 5-second chunks and then throw it all away. Our state sync has live running processes. So instead of trying to take your application, which, there's plenty of financial applications where you can really break it up in chunks and that's great, there are plenty of applications out in the world where you can't do that. And trying to take it and chunk it up, that leads to a lot of complexity. It leads to some of the billions of dollars in bugs that we've had across the crypto ecosystem. And so we enable just long-running process. You've got and we'll talk about that in a minute. More about that in a minute. The other thing is we launched the heart of our economy. So we had already launched IST, the interstable token. But we were launching more of it. And so one of the core things that's part of not just the stable token infrastructure, but also something available to other smart contracts, available to the things that you and I and other people in the industry will build, is an Oracle network. So this was led by Simply Staking, and it's basically a Chainlink style based on Chainlink architecture and run by Chainlink node operators along with support from Chainlink folks. An Oracle network native to the Agoric system to provide prices for Atom and ST-Atom and Osmo and all those kinds of things into smart contracts, including, of course, the economic smart contracts. And then finally, we released an important, this core part of the financial infrastructure, which is vaults, and I'll say a little bit more about that in a moment. In fact, I'm going to hit those topics pretty much in reverse order, right? So interprotocol is a stable token, MakerDAO style stable token where you have over-collateralized backing, and you have what's called the PSM, the Parity Stability Module. control. So the limit of a stablecoin, the limit of its utility is how many ways can you mint it. If you've got an asset, if you have something of value, can you use it in commerce on other chains? Can you use it in commerce for your own purposes? And so, USDC, dollars in a bank account, that's great. If you have a lot of dollars in the bank account, lucky you. If you don't, however, but you have a lot of Atom locked up somewhere, it sure would be nice to turn that into value, and that's what vaults do. I can bring Atom over, lock it up in a vault, mint IST against it, and go out and buy things, right? I can go out, or I can buy more Atom and lock that up, right? Or I can do whatever, right? Pay gas fees on Agoric, launch smart contracts, and so forth. So, and it's ever evolving. IST launched in November with sort of the core, some of the core minting ability to be able to take USDC and trade it for IST. And what we launched in June is the bigger footprint, which is the Oracle, the liquidation network, and this MakerDAO style vaults. And so that's huge, right? That's really huge, not just for Agoric, but it's targeted and supported and integrated with the rest of the Interchain ecosystem, right? As I said, a few thousand years ago, we discovered that having currency as the basis of your trade made for a much more efficient economy. DeFi Summer discovered that if you add currency into a trading community, you can get much faster growth, much better yield. And so we're really excited to be able to bring this kind of technology as the first use case on Agoric to the Interchain community. Okay, but this is more of a developer crowd. This is more of a Cosmos internal crowd. So I'm not going to do any more of the usual things I talk about. Instead, let's get ready to program. And the boxing's in the other room. Okay, so I mentioned the interprotocol and vaults. One of the key things that happens with vaults, and I'm just talking about the programming of it, right? One of the key things that happens with vaults is, you have like $200 worth of Atom, you mint $100, and let's say the liquidation threshold is $150, right? If that $200 falls below, Cosmos go up, Cosmos go down, right? The Atom go up, Atom go down. These are volatile assets, and so if it falls below the threshold at which it's worth enough more than how much you minted against it to be able to cover that debt, the system will automatically sell it. That's called liquidation. How does liquidation work? Well, the price moved because the Oracle network that we built signals to the chain, hey, there's a new price for Atom. There is a trigger that says, oh, did that cross the liquidation threshold? If so, I'd better liquidate. And that turns out to be, this kind of thing is multi-contract, and it's multi-block, right? This happens over a period of time, whether it's, seconds or minutes. It's more than that 5-second block you get, that we have on most of our chains. So you could imagine in CosmWasm, in Go, in EVM, turns out it's hard to do something in 5 seconds and then write it all down and then have something happen later and you have to wake it all up and make sure you keep it all straight and do the next thing. But in mainstream programming and in JavaScript, we do that sort of thing all the time. And that's pretty much the heart of one of the elements of the thing. So let's talk about that, right? This is JavaScript, standard JavaScript, snapped out of VS Code, the #1 development environment on the planet. And that'll wait, right? Price authority is our name for an oracle. This oracle happens to be the one that was the Atom oracle that is fed by these node operators simply staking P2P, et cetera. And we just say, yeah, give me a promise. That's a JavaScript async concept. Give me a promise that will resolve when the value of the collateral exceeds or goes below the trigger value, when the value is less than the trigger value. So if the value of that Atom goes below 150, resolve the promise, right? So now I'm just going to wait for that. And this thing will just sit there, and it can sit there for days or weeks or months. It's just data in the blockchain that knows that you're waiting for that to happen. And when that finishes, when that happens, this smart contract running on the blockchain will proceed ahead and call the liquidation function. And it'll just hand off to this asynchronous function saying, okay, I'm done now. Off we go. Now, this is what millions of programmers expect. This is what simplifies debugging, simplifies understanding of interesting orchestration across a broad number of platforms, and this is what, because we've enabled having long-lived, durable, blockchain-replicated execution of secure JavaScript, of hardened JavaScript, this is what we can now do in smart contracts on Agoric. Okay, but so what happens with that liquidate, right? Well, that liquidate, so I did an async query of the Oracle, and I get woken up when the Oracle happens. That's actually another contract. How do I interact with other contracts? Well, I want to send messages asynchronously, of course, because anything less, it turns out, is responsible. The Ethereum-style synchronously call another contract is responsible for a lot of the $9 billion plus in losses due to smart contract bugs. And so here instead, I get to do this thing called an offer, right? So smart contracts in Agoric, this is back to that idea of in JavaScript, we have frameworks that really help us build programs that we can plug together nicely and keep some safety properties. So an offer is, you may be familiar with the concept of an intent that you see floating around in the crypto ecosystem. Offer is approximately that kind of thing, and we're talking with the intents folk to see about, where do we borrow each other's ideas. But it's basically, rather than just saying, here's some money, knock yourself out, send money to a random number and hope something good happens, it's instead I make you an offer. I will give you this atom if and only if you give me that NFT. And the atom goes into escrow, and the smart contract goes, do I have that NFT? Okay, yeah, here it is. Here's the NFT, give me the atom, and then the underlying system enables that swap, and we both get what we want. And if you don't get what you want, if I give you an NFT that is not the one that you required in your want, then the system automatically gives you your money back, right? And you don't have to deal with getting rugged by the contract, having an upgrade make it work differently, having a bug let someone steal all your money, because the contract never has it unless it gave you what you wanted. And that is one of those safety properties that you would really like in contracts, and we just don't have until some of this intense stuff or some of this offer stuff comes out, right? Okay, so we have that pervasively in how contracts work with each other. This is, again, asynchronously sending an offer from one contract to another. It gets a promise for the result of that, which it awaits for, and so that other contract might be an auction and has to wait till the auction closes. My contract doesn't care. Just, when you get back to me, you either give me what I want or I get my money back. So when the auction closes, I get my thing, right? And that ability to be sort of insulated from the timing and vagaries of execution of other smart contracts or timers or the real world is just awesomely simplifying from what I've heard about people programming on this stuff, right? And then finally, when this offer completes, I come back and I'm just going to wait for this liquidation to finish. So this kind of core lets us do very nice compositional programming across multiple smart contracts as people start to realize larger and larger dreams of orchestration across many applications. And that idea, that term orchestration, I really like it because there's a lot of the software world that is not built in JavaScript. Now, there is this rule called Atwood's Law, that anything that can be built in JavaScript will be built in JavaScript. And we've seen libraries and medical devices and these kinds of things programmed in JavaScript. But JavaScript via Salesforce and Bloomberg terminals and all that sort of thing controls trillions of dollars every day, some of which are then implemented in languages underneath. There's transactions implemented in Rust. But the orchestration is what's valuable to people here in this room, right? Okay, so what's some other orchestration? And let's see how I'm doing on time. So we have a bounty. We had a bounty use case where, okay, I can send messages to other contracts, and other people have been able to do that. But what about to other blockchains, right? Well, so this use case, it's a very simple one that's directly valuable to customers of Akash, right? Akash lets you buy and sell, buy, rent, whatever, compute time on unused cloud machines, right? You've got some company that needs a bunch of machines to close business at 4 p.m. Those machines are twiddling their thumbs at 10 a.m. I might as well rent it to you so you can do some AI training or whatever it is. And now, they've got, fancy GPUs and higher-end things, and their service is growing. But one of the problems is if I rent and have compute running, the price of compute could change over time as there's more demand for the service. What happens if I run out of money? Then my job dies. And so a simple example that helps Akash customers who are not blockchain folk, they're just people that need to rent computers, right, is one that will check their balance, top up their wallet, right? Top up that job, and it could potentially do this to multiple jobs. And so that's, as an example, let's go ask the balance. If it's below a threshold, put some money in it, right? Very simple. Turns out that's harder than you'd think in most of these programming languages because you have to do it in little 5-second chunks, right? And here instead, no, it's just what I said. I keep pushing the wrong button here. It's just what I said. Find out how much it's got, see whether it's less than the threshold, and then call this fund the account. And that fund the account bottoms out in another one of those make an offer, or it bottoms out in send a message on IBC to do a transfer over to this account over on Akash. This code doesn't care. Either one works, and it's used both. They've got multiple versions. And so this kind of logic, where it really maps to the business logic of my application, is really powerful, as opposed to having to map my business logic to your programming framework, which is a real pain in the butt. Okay, so, oops, other button. There we go. And similarly, okay, so what does that have to do with here? Well, being able to send assets, lots of people are doing that now, and that's straightforward. But being able to do things on other chains and orchestrate that in JavaScript using components that lots of other people build, that's sort of the next step up. If I should have those brain icons, right, from the other places. Anyway, and so Oracle triggers, I want to unbond Atom on Osmosis, move it over to the hub and stake it, right? And yeah, okay, that bottoms out. There's again sort of this operation which is send a ICA packet. I didn't expand that out. Send an ICA packet to unbond. When that finishes a week from now, because it's 7-day unbonding or 14-day unbonding or whatever, then send the atom from this chain to that chain, right? Tell the Osmosis, as if I'm a remote user, hey, Osmosis, move it over to the Cosmos hub. And then finally send to the Cosmos hub, and this is a more expanded example of, this is the low-level version of this stuff, and what's happening is people in the community are building nice, composable, high-level abstractions, but the low-level one, it turns out there's a bunch of programmers that prefer it, which is why that's all, I've got example code of that flavor, right? But it's, here's my arguments for a normal Cosmos thing. I can look it up in the existing RPC documents in a bunch of places, and now I'm just going to send an ICA packet to do the message delegate operation, right? And that will then, as me, stake my tokens on that I have transferred here. I did the transfer there, waited for it to finish, whatever the 10 minutes or whatever is, and then did the delegation. And that was all done automatically by someone who started this stuff, right? Who just kicked off this smart contract operation. Okay, so a lot of those examples, some of them came from bounties. Some of them are, built, deployed in testnet, and we'll be looking and heading towards to production. So, but a bunch of them, I will say, were built by the team Calypso, that is building Calypso, and where they got a whole bunch of wiring so that they can take pretty much any asset, move it to any chain, trade it for some other token, and do some action on the chain. So unbond from Aave, sell those tokens as USDC, move them over XLR, over onto Osmosis, buy Atom, move it back to Atom, and stake it, right? And all do that with one signature, one authorizing action expressed to a smart contract on Agoric that then does that orchestration. And just last week they rolled out, Joe Snetzler, who's one of their developers, rolled out an example of all that nice, send ICA. Well, they had an equivalent, send GMP component and do some arbitrary operation. And so being able to continually integrate everybody's message bus, everybody's mechanism, where XLR, wormhole, GMP, all these things, Squid coming in, with more enhanced functionality, and bring it all in so it looks uniform and programmable, so you can do all the orchestration in JavaScript in a smart contract, run on a robust platform. That's really awesome, and they're doing they've done a bunch of those examples. The other thing, ironically, I put it here, that one of their developers worked on is the MetaMask snap for Cosmos. So MetaMask has 30 million users. We love Keplr, but we also love 30 million potential users. And the snap is the plugin to MetaMask that will allow you to do signing of Cosmos transactions. So for those 30 million people that are not yet in Cosmos, they could discover an application that bridges from Ethereum into Cosmos and just go right in and do it, right? They don't need to go, oh, you have to install another browser plugin, right? And so they could get in, they could see an NFT that was remoted, that on EVM over XLR, or buy it, move it back over to Stargaze and play with it. They could see a hierarchical NFT created, and I'll mention mention this in a moment, a nested NFT created on Agoric, bring it over, buy it in some remote thing, bring it back to Agoric, edit it, add history, change what's on it, all those sorts of things. So that MetaMask snap is built on the same hardened JavaScript that Agoric created. So we created it in conjunction with folks like MetaMask, Salesforce, Bloomberg, Figma, etc., to be able to do JavaScript extensibility using third-party code. We use it for smart contracts, and we work with MetaMask to help them use it for extensibility in the wallet. We also have Cread. I see some of them here in the audience. They are building an NFT toolkit. So what we're doing next, right? June was awesome, but Q3, we're working with partners that have helped us shape our toolkit. They've built our overall ecosystem of software and our software components, our DeFi and NFT Legos, if you will. And they're now heading towards production, deploying on production these third-party applications on our general purpose platform. And so one of them to look for is Cread, which is an application for editing well, I can't even explain how awesome it is, for doing nested NFTs. And also a general NFT toolkit, where the reusable components that they build in order to accomplish their application become something available for other people doing cool new kinds of NFT applications in JavaScript. And then finally, we're building out in this next quarter the developer platform targeting these Web 2 JavaScript developers that are all interested in Web 3, right? There's as I said, 6,000 developers that could do Solidity. There are millions of developers that could do really good applications, of which a lot of them are interested in Web 3, if only it could help them solve their problem rather than them having to buy into ours. And that's our focus, is going to be enabling them to be able to take this technology, to bring it to the stuff where they're already innovating in JavaScript and just bring in Web 3 and become part of our larger extended ecosystem. So we're really excited about that. We're really excited about this orchestration that we can now all build for this interchain, for the interchain that we're all living in. And please join us. Please go and look at the set of components that people have built, the developer tools and the documentation that will be evolving over the next Q3. So thank you very much.